and we want to go more into depth today about the product, and Frederick will guide you through the setup of the product and to the questions you have. I think it's a very exciting technology that we're starting, and yeah, let's just start right away, and Frederick, yeah, the floor is yours.
So maybe before we start and dive into the RIWOtrack system, maybe a little explanation about the WebEx system. At the moment, maybe if you're not familiar with WebEx, you will see us in a small window, and I'm quickly going to explain you how to make that a little bit larger. I hope that my colleague from the technique can share our screen real quick. On the right top corner of your screen, you will see a magnifier glass, which goes with plus and minus. And if you click the plus, you will see our screen, or the one that is speaking, the last, you will see them in full screen. And here it goes. We're sharing our meeting window. This is the initial, how it looks like. And if we go to the top right of the screen, a little bit more to the right-hand side, if we just go to the magnifier glasses, just next to layout, and we just click the plus sign on the magnifiers, that should do the trick. Left from the layout, a little bit left, yeah, and now exactly. So then we see the last person that spoke, because none of you have used sound so far. But if you do this, you will only see us in full screen. Okay, let's go ahead. So now it's your turn to press the magnifier glasses to see us in full screen. If you have questions, please type them into the chat. I see there is a hand raised by Ahmed Abdelal. I hope I pronounced correctly. If you have a question, please write your question into the chat and we'll be able to answer it live here. Okay.
Okay. Or otherwise, they can raise their hand. They ask the question.
Sure, of course.
Yeah, I think it's also okay. So I don't know, Ahmed, if you raise the hand to say hello, or if there's a question. If there was a question, just raise it again, and we will try to answer it.
Okay, so you've already heard the RIWOtrack system. It's an electromagnetic navigation system for navigating instruments with respect to the patient's X-ray images that you have made at the beginning of the procedure. And let's quickly show you the system. So the main component that we have is the RIWOtrack system. It's the control base. It controls everything. It's the Cube 4D that will control all the signals that are incoming and show and forward the images to the screen that we have right there. So this is the start of the surgery. You have the big screen behind there. And here we have a couple of plugs. So one time, this is the VirtuLink, we call it. It's a hub for all the sensors that we will be connecting. So we have 3 further ports here to which we can connect other sensors. We'll do that later in a little bit. You will see also the sensors just in a little bit. To this port, the patient reference is connected. The patient reference purpose is to bring the position of the patient with respect to the X-ray images that we're going to shoot. You will understand later because we are going to reference the patient here live as well. And this is fixed here on the patient with a guide wire, with a K-wire, which is in the spinous process, one level adjacent to the one we're working at. But also the software will guide us through all these steps. This is very important. The software explains to the surgeon every single step that has to be done.
A question, Frederick. So we see this here, it's standing beside the tower. Do I need a special, do I need a special table for the RIWOtrack, or where do I position that on the OR?
You can place it on the tower, or you place it on a special table, depending a little bit on the setup of your tower. But usually there will be space on the tower, and you can place it on the tower.
And how is this connected to my tower? Do I need a wolf tower, or how does it work?
A wolf tower would be best because the image quality is the best. And we get the HDMI signal, the 4K signal from our Logic camera, and we have it plugged here in the back end side of this box. And there's another video output which goes then back to our system. We have two options to have this 4K image. Namely, one is to place it on the endoscopic tower. The other option is to have a separate screen solely for the navigation. We would prefer the endoscopic screen image. You will also later see there is no reduction in quality to the 4K image from the endoscope, and you will see the navigation at the same time. It will be like a side mirror from a car, but you will see it later.
Okay.
So let's jump into the sensors that we have here. I would separate this into two parts, namely these sensors. They are necessary for patient referencing. This is called the mapper bridge. This is the lateral mapper bridge, and this is the AP mapper bridge. They have X-ray opaque markers on there. They're the X-ray fiducials that we will see and that are necessary to calculate the position of this tool on top of the AP X-ray image that we see. And also here there is a positional sensor inside which we can track with the field generator. So the field generator is connected here on the left lower edge of the cube 4D. And it goes here to the sacrum of the patient, just a little bit over the patient. It emits electromagnetic fields, which then can be tracked by the sensors that we have in the field, such as the patient reference, which we connected here on the K-wire, but also the other sensors that I will show to you just in a second, and as well as the mapper bridge.
So Frank, this is, what is this, sterile, non-sterile? How is this reusable, single use, or what?
All of what we have here on the table is sterilized, can be sterilized with the autoclave. And so it can touch the patient at any time. Just we have to make sure if it's unsterile, we cannot place it again. But of course, there's no need to plug it again if you do it correctly the first time. Then they are reusable as much as you like. So all of the things are reusable. Then we have the sensors here, which come into play for tracking and navigating the needle, as well as tracking and navigating the dilator and the working sleeve. And they can be reused 10 times. All right. The instruments that we have here, I was just explaining the AP mapper bridge. The lateral mapper bridge has fiducial markers, and they come on the side of the patient and have sensors inside which will track the position of these plastic plates with the fiducial markers. So after we've referenced the patients, which we will do just in a couple of minutes, we can use these sensors. We can place them inside the needle that you already know. And we can trace that image, or we can then trace the needle on top of the X-ray images that we've produced.
Does this has to be absolutely this 18G needle? Yeah?
Exactly. It has to be exactly this 18G needle. Exactly. Then here, this is going to replace the handle of the working sleeves. And later we will see in the software, it will explain how to place the working sleeve in there. We can lock it, and then you don't need the handle for the working sleeve anymore. And inside this handle, we have the sensors that are making it possible to trace the position of the working sleeve. Further, here we have an adapter to the regular 7 millimeter dilator, into which we can also place the same sensor which we've used before to track the needle, to track the dilator later.
So we can track the needle, the dilator, and
exactly.
the sleeve.
Yeah. And one more item that you see here, there's a sensor inside as well. This is the multipad, and it's necessary to, if we have a tool change, we need to know which tool we are using. So this has to be in the field of the field generator. We place the needle on top like this. And once we do that, the system knows which tool you're using, because the relative position of the sensors that are inside the needle, they have a certain position to the plane of the multipad.
Okay, so to clarify, this is all sterile, and this is all reusable, and everything is reusable, and these two things are reusable 10 times, correct?
Exactly.
Okay, there is no way I can cheat. Is there, how does it work?
Well, so there is a counter inside. in the tool, and once you plug it and you've done a patient referencing, you can use that patient, or you can use the same referencing for, I think, at least 4 or 5 hours. So if your operation time is 5 hours, which I hope that will never happen, but you can do that. But if you reference another patient, then it will count down.
Okay, it's per patient then. Yeah.
Yeah, exactly.
Okay, great.
Good. So let's start with the patient referencing.
So imagine we are in the OR. Okay, our patient is already positioned, prone position. We have our RIWOtrack on the stack, on the sides, and then what is the next thing we do? So we have a usual surgery, so I see or there's already something positioned here.
Yeah, so maybe the surgical team has already a little bit experience on the RIWOtrack system and has positioned the patient like this already, but even if not, the software will guide us through. So I will now show how to use the software. We have a question, I hear. It's steam sterilization in the autoclave, so we need the steam sterilization. So the nurse will use the mouse and will select, okay, today we're going to do a transforaminal case. In this case, we're here working on the right-hand side of the patient, so we click right, and already we see that instruction which sensor to plug where. So it's really detailed. The surgeon sees exactly what to do, and with explanations with which distances to connect.
So we have the workflow on the left side, correct?
Here we see the workflow. This is the general workflow, and this is the instruction to finish this step in the workflow. It looks like a very long workflow, but if you do everything right, this goes very fast. And
how much is fast? How much?
Well, so we've done the first cases, and we've seen the very first case. It took a little over 20 minutes, but then later, after the third, fourth surgery, it took only 12 minutes. So 12 minutes you can do after 3-4 surgeries. And I think there's even a little bit more room to improve, probably towards 10 minutes. So you need a little bit more time to do the setup, but you'll see later, the surgeon will save a lot of time placing the needle.
So it's an important point. I mean, imagine other navigation, options. They take a lot of time. This is an argument often against navigation. But if you tell me it's 12 minutes, I think it's fair.
Yeah. So the system has recognized that the field generator, the navigation sensor, is already attached here. That's why I can click on Next. And now here there is the explanation of how to place the K-wire. So the K-wire goes into the spinous process, one level adjacent to the level we're working on. This is only symbolic on level L4, L5. I think here we've placed the K-wire in the model on level L3-4. It is all of this. The field generator is one of the things that is not sterilizable. It goes under the patient cover, so the patient will be covered right after, and then the patient will be sterile after that. But there is no contact of this to the patient due to the cover being over there. The patient reference is sterilizable as much as the surgeon likes to.
So there's another question. So how far should we position the navigation sensor from the patient?
So the software explains to us before. Maybe I can go here a step back. And here it says it has to be 20 to 25 centimeters to the
working area. Yeah.
To the working area of the level that we're working on. I will move the patient now wrong to show, because usually we will go through the software really quick, but in case that it was mispositioned, so here there comes the explanation where to plug in the patient reference, where to place in the K-wire. It recognized that the sensor is attached. I click on Next, and now it sees that the reference is far away. So we have to probably readjust the patient, or we have to readjust the field generator. So then, once the patient here is in the correct position, you see this here, that the sensor now here is on both sides in the green spot. We click Next, and that's what it does automatically if you've placed the patient correctly the first time. We choose the C-arm that we're working with, because all the C-arms that we're using, they are calibrated. So some of the C-arms, they have a cushion distortion or a S distortion, and the system is calculating out these distortions. So the X-ray image that we will see later is probably even more precise than the actual X-ray image that you will see due to the calibration. All right, we've selected the C-arm, and now comes the explanation of how to place the mapper bridge. We will do that right now. So, for larger patients, I can extend those arms of the mapper bridge, and for smaller patients, I can place it together like this.
You know the maximum width, like allowed?
The maximum width that we have here is a bit more than 50 centimeters.
Okay.
So that should be enough for most of the patients, I hope. All right, so as we can see there, it says to place the reference sensor there. It says to place the mappers, and we simply plug them in here into the VirtuLink, like this. Then we take the AP mapper, like this. Now the system knows that the mappers are attached, and there is no distortion, showing that the sensors that you see here, they are shown in green. If there's any distortion by metallic interference, such as probably the C-arm in AP position, then the AP mapper would show red. So everything is fine, everything is green. We can click the next button. Now it says to take the lateral image, which we are going to do right now. In modern hospitals or modern C-arms, they have the possibility to do a PAX push of the images later, not later on, but do a PAX push of the image to the system. We have an older model here, that's why we're going to transfer the images with a USB stick. A little bit more caudal, please. Yeah, like this. All right, let's take one X-ray shot. So we can see here the level that we're working on. And I think we have enough markers, so we're going to transfer this image now.
Sorry, Frederick. So the goal here is to find enough markers.
Exactly. So the fiducial markers that we have here in the mapper bridge, they should be visible on the X-ray screen. I see a couple of markers. I think that's fine. And then we're going to transfer. Please leave it in the lateral position for now. So now we're transferring the image to the system. It's calculating the registration for this patient. There's some complex algorithm behind it. That's why the computer needs a little bit of time. And there we see in green here in the software, all these green spots are the fiducial markers that are recognized. Then here there's a yellow spot. That means this spot, there is a little bit of distortion in the image. But it's not a problem. We have enough green spots. Everything is green here. In case that the precision would not be good enough, this would show up in yellow or even in red. And here we can see the overlay of the direction of the K-wire that we have. We don't know the depth of the K-wire, but we know the direction of the K-wire, so that fits. And also here, the screw that we have on the reference sensor, here we can see the overlay is quite good. So we confirm this one. We're now going to move into the AP image. All right. Let's take an AP shot. Let's take an AP shot.
Okay.
The sound is back again? No? Okay.
Yeah, so in the meantime, I will try to go a little bit, because I see here the image, and you see the dots here. Not all of them are on the image. So I think Frederick will ask me to go a little bit more caudal. Right, Frederick?
So my sound is back, I hope. I think that the markers might be enough, but let's go a little bit more caudal. Cranial, sorry, a little bit more cranial and caudal, a little bit up here, this way. Yeah, thank you. Okay, I see a lot of markers, so probably that's fine already. Let's transfer the image. In this case, because the C-arm is now in the field of the field generator, and there is a lot of ferromagnetic material here, so we have to move the C-arm away. And if we took the image, so it says here also, please push the C-arm away because the sensors were red. You saw that in the software. Now the sensors are fine. We click on next. Now it's calculating the AP registration. We see already the trajectory of the K-wire here. We see a lot of green spots and the overlay of the AP map. And that's very good for me now. So this could have all been done by an assistant surgeon. And we don't need the X-ray garment anymore. No X-ray protection needed. Now we can continue the surgery like this. All right, so we confirm that the is correct. And now we're going to set the target. So we're working here on this level.
Right, sorry. So you're saying that, I mean, we did 2 X-rays, okay, on the patient.
We did 2 X-rays on the patient.
And you're saying that's all we need, yeah?
That's all we need.
Okay, that's great.
All right, so now here on the AP and the lateral images, I placed the target for where we want to start entering into the disc. It doesn't matter where I place this point. The surgeon selects, of course, where to place these points, but this seems like a good place to start. And now even there is an explanation. Please unplug the mapper bridge. So we're doing right that. And we remove the mapper bridge from the patient.
There is a question, Frederick. Later and AP, I mean maybe lateral and AP, we take the picture by USB stick, I think he needs, and insert in the navigation.
So in this case, we transfer the image with a USB stick because our C-arm here is not capable of a DICOM push. But with a modern C-arm, there will be a DICOM push. That means on the C-arm, you click the button, send to RIWOtrack, and RIWOtrack will receive the image.
Yeah, and if you have an older version as we have, you need to do this manually by USB stick, but it also works. Usually, if it's not older than 15 years, it works directly.
Yeah. So on the software here, we see also it explains to us which sensors to plug in. So I'm doing right that. And
one question, Frederick, this here, the virtual link, is this in a sterile, non-sterile area? How does this work?
The virtual link is in a non-sterile area, to which we then can connect here the sterile sensors that we have.
And the sequence, what I connect on which opening?
The sequence doesn't matter, and it shows us in the software which of the tools have been connected, and once that we've connected at least one of the sensors, because we can choose to navigate, for example, only the needle. After that, it will explain to us, please place the reference sensor inside the needle, like this. And I explained to you before, we place it on the multipad, like this, to tell the system which tool we're having. And here we have the needle, of course, it recognized that. And I can find my entry point in a very regular manner. So here I see the advancing trajectory of the needle is parallel to the disk space, and I'm here on the level of the spinous process. So that's my point where I do the incision.
So you take your normal incision points?
Actually. Normal incision points, just like before, just without the X-rays. And then the next thing, when I advance the needle, the only thing I do is take a look at the guidance target that you see here. So it tells me...
This thing in the middle, right?
Exactly, yeah. As long as I keep it green and then advance, I will always hit the target that I set before. And we see the distance to the target, which is now 91.2 millimeters, roughly.
So that's like 9 centimeters.
Yeah, and now I'm going to show you how you can do that. You enter into the skin, and you have to keep it green the entire time. As long as you do that well,
wow, Frederick, you're good.
Bam.
Yeah.
Now I feel some resistance at this point. I will enter into the disc.
Now you passed, you're right.
And that's the position we have. I remove the sensor. Because I removed the sensor and I was close to the target position with my needle, it already explains to me what to do next. So I then place the the sensor into the dilator, like this. I reference the dilator on top, and now I can trace here the dilator. So just like in the regular procedure, I use a K-wire, which I place into the patient like this. I know here it touched the disc, and I place it 2 more millimeters inside. And then I remove my needle, like this. And again, when using the dilator, I have my guidance target, which helps me to find the right spot. So here now you see it's green, and as long as I keep it here in the green and I push and advance my dilator, I will hit the same spot. So now you see, usually you will need maybe in a regular surgery 8 to 10, maybe even 12 x-rays, and it will take probably 15 minutes. It depends a little bit on the experience of the surgeon. I've seen cases where the surgeon was very unexperienced. It was one of the first cases, and it takes half an hour before you find the right spot. But being on the right spot is very crucial in a transforaminal surgery. So here, we're not in the foramen completely yet, but we want to be in deeper. So I place it in a little bit deeper with the hammer, just in a regular way. I remove the K-wire. I remove the sensor of the dilator. I remove the adapter. And now the software tells me what to do next. So everything's self-explanatory. I place the working sleeve onto the handle like this. So with the opening opposite to the handle that we have here, even the software alerts me to take care of exactly this. I lock it to the working sleeve, and I reference, or I calibrate actually the working sleeve on the multipad, and then it tells me to do the same thing again, just pointing here. Now I feel resistance here. So now I rotate 180 degrees via caudal.
So you do the same as you do in the usual surgery?
Yeah, and now I'm in the foramen. I could also hammer here right on the handle if I want to go a little bit further, but I think my position is okay. I remove the dilator. And now we automatically get the endoscopic image. So we see that we have the endoscopic image on the left-hand side and our navigation on the right-hand side, like this.
How do you say automatic? How does he know that you reached the target, or how does this work?
As the sensor of the working sleeve is in the field and the flex sensor is not in the working field, it knows that we're not needing to navigate the needle anymore. So that means we have the working tube in the working area, and we don't have the needle in the working area, and that means that we're working with the endoscope
already.
Right there. All right, let's
show us.
Go inside. We see here we have the PLL. The red thing is the dura, or the traversing nerve root. Here,
yellow.
On the left-hand side, this is the caudal pedicle. And now if we rotate to the right, we expect to have the exiting nerve root. And yes, we see here the exiting nerve root with a disc that has been used before already.
So let's say we are in the surgery. So we started our surgery right now. And what happens on the right side? Actually, we have our 2D image, one AP, one lateral, and your sleeve is always live tracked. Yeah, if you change the position, also it shows you the position of
exactly, yeah.
So it's not only for the approach, it's also for during the surgery. So whatever we do now with the sleeve, we see the opening, we see the position. Yeah, even if it turns the opening,
can rotate to here.
There's no more X-ray needed. Yeah, that's really fantastic. Yeah, even if you do now foraminoplasty, you can see always where you are. Very convenient.
Just like that, exactly. So it gives a lot of safety to the procedure, and also for the transfemoral approach especially, it saves a lot of time to use the system.
And it's easy.
And it saves X-ray for the patient as well as for you, for the surgeons.
So one question, Frederick. Okay, that's transfemoral. What about interlaminar? Can I do interlaminar?
Of course, we can do interlaminar in the same manner. We have the same tools that you can use if you'd like to trace the dilator, or if you want to trace the needle if necessary. Usually in the interlaminar approach you don't need the needle, but you can trace the dilator, and you can also trace the working sleeve just like this.
Okay, and is there any advantage of having this in interlaminar?
Of course, yeah, it's safety. So we know that for the access in the interlaminar approach, we don't need so many X-rays for the access itself, but we need to confirm sometimes the depth of our working sleeve, the position with respect to the spinal canal. But also on the right-hand side, I have a live figure. So if I would be working interlaminarly, so maybe you go here and you go into the patient like that, and then here you can see live what is the position of your working sleeve.
That's great. Yeah.
And you always have the right orientation. So I've seen in some surgeries sometimes the surgeon starts to go too far cranial or too far caudal, but you have this information all the time. So because you have this information all the time, this adds a lot of safety, and probably this technology will save 1 or 2 or probably more of the exiting nerve roots. I'm convinced of that. So yes, it's a must-have actually in future. In 5 years, I'm convinced everybody needs this for additional safety.
Yeah, and also it makes it accessible for everybody, because we know the main issue for beginners in endoscopy is orientation. Yeah, it's absolutely you're lost. You don't know where you are. Okay, you see your image, but okay, then you ask your system, okay, let's do another X-ray. It's bulky, you have no space. Then you cannot do AP because you have your endoscope here in interlaminar, for example. That's not always as easy. And here you have always the live image where you need to start the drilling also in interlaminar. What about stenosis then? Yeah, what if I?
Yes, stenosis is also possible. There are some other sensors. They are not available as of today, but they will come within this year, and stenosis will then be possible.
How do I know, Frederick, if this is accurate? Tarek is asking.
Well, so the registration itself, the registration itself confirms its own back projection, it's called. So we know that the fiducial markers are there, and it checks for the fiducial markers and can estimate the accuracy, because not all we saw on the registration that one of the fiducial markers was shown in yellow. The other part, how you can check for the accuracy, is the overlay during the patient registration. During the patient registration, we saw there was a yellow overlay here on the needle, on the K-wire trajectory, as well here this screw that we have on the patient reference. That is a good point to estimate the accuracy. We here usually lie within 1.5 millimeters of accuracy.
Yeah, and so he says that sometimes the navigation lose accuracy. I think the guys from the Middle East, Tarek from Amico, they have a lot of experience, I think, with optical navigation. Maybe is this referring to that, or what can he mean by sometimes it loses accuracy?
Yeah, so sometimes the navigation loses accuracy. That is the statement of Tarek Sayat. We've not seen that so far. What can happen if you remove the K-wire after the calibration or after the patient referencing? If you remove the K-wire, of course, your patient reference has moved, and then the system doesn't know the referencing anymore. So that's the point. You should not remove the K-wire after the calibration. It has to stay exactly where it is. It can. So the question that we have here is, can it be connected to the Medtronic O-arm? It can be connected to any C arm that produces a lateral and an AP image. So we're doing we're trying to reduce the X-ray exposure, and that's why we only have one lateral and one AP image and not more.
And maybe another thing to to be more accurate. I mean, you have here a second hole. I think that's also for a second key wire, maybe.
Yeah, if you do a lot of drilling, I will quickly remove this. So we're losing now the accuracy of the calibration that we did before. I'm going to show it to the camera. I hope you can see this. We have 2 holes in there. The central hole is for the K-wire that we placed just now. And if the surgeon plans on doing a lot of extensive drilling, we're placing a second K-wire just adjacent to it to fix it even better into the spinous process. And that prevents from any rotational movement of the patient reference.
Okay, great.
So you see now I removed the sensor, and then we see that there is no navigation possible anymore. So take-home message is do not remove the patient reference, because it's the reference, it's our anchor point for the entire surgery.
Okay, yeah, thanks, Frederick. I think was very exciting for you as well. We have different marketing materials for you at your disposal. As you know, there's the marketing info that you can use. They have all the information. Again, really in one document. You have the brochure for us. You will get another one that will have all articles. At the moment, we just have the flyer. And of course, you have the RIWOtrack.com homepage that is very extensive in terms of videos, of material, everything explained once again. Also, you can use this to show it to surgeons. We will come up, of course, with much more information and marketing material for you, with live surgeries and so on. And yes, and I think that's what we can offer so far. There's more questions, Frederick. So in case of percutaneous fixation, can we track the wire in the pedicles? Yeah, I was waiting for that one.
So, at the moment, the system can trace the tools that you've seen. It can trace the working sleeve, it can trace the dilator, and it can trace the needle. And we have a tool planned already, which will be a dissector, in order to point onto things that you see with the endoscopic image and to know which structures you're pointing at. And those are, for now, the tools that we can navigate. Yeah. And then there's the question, how can I do it if there's no connection between the X-ray and the tower? Well, we need some kind of means to transfer the digital image from the C-arm to the system. And we accept the DICOM push, and we accept also the USB transfer as a backup. But of course, we need the digital image in the system somehow.
Yeah. Okay, thanks, Frederick, again. So we have just a comment, perfect tool, but it's a bit tricky to get to the targets.
I would like to invite you to come over here and try to place it.
I mean, we were overwhelmed how easy it is actually to get to the target. I mean, all of you have done a lot of workshops with us already. You know, as surgeons that place needles for the first time. It's not necessarily always very experienced surgeons, you know, in placing needles. It takes some time for them. With this tool, really, it's easy. I think also from sales point of view, you know, everybody is speaking about the long learning curve in endoscopy. And I think this is a major tool that can lower this learning curve tremendously. You know every time where you are. Yeah, I mean, this is the key point of this, apart from reduction of radiation, of course, which is excellent. But I think, for me, the key fact is you always know where you are. And additionally, from sales point of view, from a very attractive price point of view. Yeah, because you have to see, the guys from Medtronic know this very well, how expensive a navigation system is. So this one is, as you know, a third of the price. And please check your sales structure for this and your sales model and your business model, sorry, because you can do this also by case. Yeah, you have seen there is not much disposables here. You have just 2 items if you do the transforaminal case, and as you know, the cost per case is like an electrode. Yeah, for the transforaminal case, and for the interlaminar, it's even half of it. Yeah, so I don't think it's a lot. But you offer something of highest technology, and you can, of course, you can voice, of course, value this a lot. Yeah. So that's my sales point of view, Frederick, to this, because it's really a nice tool. Yeah. Before we stop here, there's another question coming in. Can we make true trajectories for 2 different levels?
Of course we can. I will quickly show you how to do that in the software. So in case that there's really a 2-level part, I can click here on the 2D part. Of course, I have to remove the working sleeve to, well, actually I didn't have to remove that. I can drag and drop again here the target. So in case that we want to go 1 level down, I go to this level down. In case that we want to do an interlaminar approach, I click here on switch to interlaminar, cluck, and the workflow for the interlaminar will start, and we can work interlaminar.
Yeah. Great. Okay, thanks a lot. Thanks to all of you for joining us for this session. We hope to see you soon. I think you have all material available. These products are immediately available. Of course, when you do your first sale, our specialists will come over, do the installation with you. If you have any doubts, we will help you, of course, and stay with you for the first cases. I think it's a nice package that we offer. Yes, Frederick, anything to add from your side?
Well, I hope that all of you enjoyed the show today. I am very pleased that all of you were here today, and thank you for your interest. And yeah, thank you very much. Stay safe.
Of the product. See you soon. Bye-bye.